Okay, so basically for motion, we'll be looking at key things under motion, right? So for that motion, we'll look at the first part is going to be the definition, right? Definitions and little calculations on that. We'll look at equations of motion. There are like five sections for this very topic we're going to do, about five of them. So the first section will handle our basic definitions, right? So basic definitions and concept that is going to help. I don't have power strength to write this morning. So definitions, basic definitions around that. So we're going to look at definitions. Now, the second part of the class is going to be on equation of motion and how you can use those equation of motion. We'll look at equation of motion. And after that, we're going to look at graph, right? All those velocity time graph, displacement time graph, and the rest of them is going to be handled. I will ensure that we'll do justice to that. Then the next one is going to be your projectile. We're going to look at projectile, right? Projectiles and Newton's law. We'll look at Newton's law as well, right? Newton's law. Then we'll also look at momentum. We'll look at momentum, momentum and circular motion. Momentum and circular motion. So I'm writing this way just to give us a heads up. Then after that, we solve as many past questions as possible under motion. So more like this lesson, we should have like, these are the categories of the things we'll be looking at. We're going to be looking at the definitions, we'll be looking at equations of graphs and the rest of them. So just take note of all of these things I mentioned as the lesson will revolve around them, right? So today, um, sorry, I think the recording is having an issue. Let me reach out to Mr. Hillary. Sorry. So we'll be looking at distance and displacement, right? These are concepts. Please pay attention. This class determines whatever thing you've known on this before now. Just pay attention. No matter what you feel you know before now regarding all of the concepts we're going to be learning this morning, because everything revolves around that. Does it make sense? So the first thing I have here is your distance and displacement. The last time we studied about distance and displacement, I'm coming. Let me reach out to him. It seems he's not recording. All right. So that said, distance is the total length, just like I highlighted clearly here, right? Is the total length of the path traveled by a body. So all of these concepts, I'm going to revolve around them. So today is just going to be dedicated to your concepts, and I'm going to solve questions as well. I will show you how to use the equation of motion, the fastest way to solve questions regarding equation of motion without wasting time. Does it make sense? So displacement is simply total length of the path traveled by a body. So when you're talking about total length you've traveled, you're making reference to distance. Now, distance is a scalar quantity. Are we together? Distance is a scalar quantity, and it's always okay, and it's always positive, right? And it has what? Magnitude only. It depends on the path that is being what? Taken. So these are the key concepts around distance. And I'm going to be making use of this concept when we start plotting our graphs, like our velocity time graph, distance time graph, everything, even on our projectiles and momentum, is going to be very, very helpful for us. So these are the concepts around your distance. Now, the next thing I want you to know, as always, you know already that distance is speed times time, right? Distance is speed times time. Now, how about your displacement? Now, displacement is the shortest distance between the starting point. Take note of these key points here now. Between the starting point, you have your starting point and the final point. So, more like you have a starting point and you have a final point. And displacement happens to be the shortest distance between that starting point and the final point. And is measured in a specific direction. So these are key concepts I want you to always remember about your displacement. Now, the next key thing is that displacement, it does not depend on the path taken, unlike your distance, right? Already in our last class, I've said that displacement is a vector quantity. Some persons usually confuse displacement with distance. So distance is a scalar quantity, displacement is a vector quantity. So now it can be positive. That is where the thin line comes in. Displacement can be positive, it can be negative, or it can be zero. But your distance can only be positive because you're calculating the total distance traveled within a specific time. So I went from here to Lagos. What is the total distance traveled? Do you understand the point now? So all of those things revolves around the key difference between your distance and your displacement. Now, displacement has what? Magnitude and direction. It has what? Magnitude and what? And direction. Now, having these four things, you see the way I'm arranging them as bullet points so that you can always remember them, right? That it can be positive, it can be negative, it can also be zero, right? Why is it so? Because for you to talk about displacement, you have to talk about what the direction as well. And I said that during our class on vector and scalar quantities. So that being said, let's proceed to some questions. These are the kind of questions. I don't know who sent this question to me. Obasi, was it you that sent a question that has to do with traveled 4 kilometers, 6 kilometers? If it was you, give me a thumbs up. I know someone sent a question that has to do with someone traveled 4 kilometers, 5 kilometers, and returned back again. I can't remember who that was, but I know that sometime someone sent a question along that very line, right? So it's important we pay key attention to this. Now, example one, they said that a student walks 3 kilometers east, then 4 kilometers west. We should calculate what the distance and as well the displacement. Now, in JAM, they are going to see something like this. They will give you the values. They will not ask you this way that I asked the question. They are going to have your options. So now, if it is distance, remember that distance is simply talking about what? Distance talks about what? How long, right? Total distance covered. Remember what I said about distance? It's simply total length. Sorry, that's what I was trying to look for. Is the total ones, the total length traveled. So for your distance, total length traveled here, for us to get the distance, we are looking for the total length. So which means that the distance will be equal to the total length that this person traveled is going to be what? This person, first of all, moved how many meters? He traveled 3 kilometers at first. For some of you that their leg don't, you guys don't stay one place. I know most of you, right? You keep going from one place to another. So now, when you move to the first place, you traveled 3 kilometers. Then it doesn't end here. You move again another 4 kilometers to the west. Remember that you have your four cardinal points. You have your four cardinal points. In case you don't know, your four cardinal points, you have the north, the south, you have the east, and the west. So now it is happening along the same line. Along the same line, he walks 3 kilometers to the east and 4 kilometers to the west. So total length, distance is asking you, what's the total length that this guy covered? The total places that this guy went to, which is going to be equal to what? I'm going to add them together. So it's going to be what? 3 plus 4. So that the distance covered, the distance that's total length is going to be what? 7 kilometers, right? But now let's look at your displacement. How do we calculate for that of displacement? Now, for displacement, since you are moving along this direction, remember what I told you back then when we did vectors, that when vectors are acting in the same direction, we do what? People that have been in class before, when vectors are acting in the same direction, what do? We do what? We add them together. If they are acting in opposite direction, we subtract. Now you see that he walked eastward 3 kilometers to the east and then 4 kilometers to the west. Now, if we say that the east is positive and here is negative, you will see that the directions are opposite. So now, total displacement. So let's do it this way. So we have 3 kilometers to the east, and the east is positive. That will be what? Plus 3. Now we have 4 kilometers to the west. That's what? Negative what? 4. Are we together now? So when you bring everything together, minus 4 plus 3 will give us what? Minus 4 plus 3. Or let me not use negative sign. I don't know if I use this negative sign whether we're going to be confused. But what I'm trying to say is that remember that if they are acting in opposite direction, let me just go straight forward. If they're acting in, okay, If they're acting in opposite direction, I should have. Sorry, I can't see your answers. Someone said one. Chinonso. Okay, thank you. So displacement will be equal to what? 4 minus 3. Why am I doing 4 minus 3? They are acting in different direction. But I want you to use this symbol. If you are traveling to the west, negative, that's the west. East, positive. Now, the displacement is simply what? The shortest distance between a starting point and the end point. So you're going to subtract that ending point and starting point. So because of what? 4 minus 3 is going to give us 1 to the west. But the easiest way to do this is to what? Remember what I said. If I'm traveling to the west, I can say that for the west is a negative direction. So that's negative 4 kilometer. Then to the east is going to be what? Positive. So 3. So now my displacement will now be the algebraic sum of both of them. So displacement will now be equal to minus 4 plus 3. So that displacement is equal to minus 1 kilometer, but there's nothing like minus 1 kilometer. That minus 1 is simply telling you that it is towards the what? Towards the what? What does it tell you? It gives us that idea that is towards the what? The west. So that's what it means. So it simply means 1 kilometer to the west. If this one is confusing, use our vector notation. If vectors are acting in the same direction, you do what? You add them together. If they are moving in different direction, you subtract. So for this one, they are moving in different direction. They move to the east and they move to the west. So you subtract. And the direction is going to be the one that is bigger. So that will give us what? 4 minus what? 4 minus 3. If you understood what I said, give me a thumbs up. In any way, the both method, anyone you understand, just give me a thumbs up. Yeah, thank you, Justice. Thank you, Chinoso. Thank you, Rachel. Thank you, Shedrack. Thank you, Confident. So anyone that works for you, both the sign, the positive, or making use of vectors, add, subtract. That's all. Now the next thing here, a man walks 3 kilometers to the west. Thank you, Susan. A man walks 3 kilometers to the west, then 4 kilometers to the east. This man, na Jegede Shokoyo, he walks a lot. Why not stay one place? So he walks 3 kilometers to the west, then 4 kilometers to the east, and finally 5 kilometers to the west. You see how that young man is walking around like a reverend father that doesn't have parish. So now, but let's see what will happen here now. And they said, what is his displacement? Now, remember what I said. Remember your 4 cardinal points. So that's why I said that knowing it with that sign is better because of situations like this, that the person is just walking around like what I don't know. So now, with this case now, remember that we have our 4 cardinal points. This is our north, this is our south, this is our east, and this is our west. Remember, we said you can change the notation. It's just my own sign convention that I want this side. My own sign convention is I want this young man here to be negative. I want this guy to be negative. I want this guy to be positive. That's my own sign convention, right? Remember, it can still be along north and south. The person can still move along straight line, north and south. It can be around west and east. Do you understand? So around north and south, here can be my positive based on my convention. And here is going to be my what? My negative. So that said, let's proceed. Now, the first thing that young man did was to go, sorry, I'm changing my sign convention. Nobody's talking. So let's maintain what we know. They are waiting for somebody that will ask the question. Then you will answer, I talk. So now the next thing here, we have, yeah, that's what you guys are waiting for. So that one person will say it and others will follow suit. So now we have the first movement here was 3 kilometer west, which means we'll have a distance of what? Minus 3. Now he now went 4 kilometer to the east. Are we together, guys? 4 kilometer to the east, and that entails that 4 kilometer east will now be equal to what? 4. That's positive. Is that not so? So the next concept here, and finally back to the west. So 5 kilometer to the west. And 5 kilometers to the west, that will be what? Negative 5. So let's bring everything together. Let's get the sum of everything. So that means that if you don't know your sign very well, there will be a problem here. We'll have minus 3 minus 5 plus what? 4. minus 3 minus 5. I wonder how some of us are not good in maths. You're owing somebody 3 naira because
Minus
you
8.
borrow a lot. Because you borrow a lot, you still went ahead to borrow. You can raise a hand. Yes, yes, yes. You can raise a hand if you don't understand. There's a button for raising of hand. Thank you, Stella. God bless you. So you borrowed 3 naira. You went ahead to borrow another one, Mr. Borrower. So that will give us what? Minus 8 plus what? 4. So you're owing somebody 8 naira, and then you manage to pay 4 naira out of that amount you're owing, which means in total you're owing how much now? You are still owing what? Minus 4. So that means our displacement. Remember that sign is giving you the direction, because displacement is a vector quantity. You have to tell us the magnitude and have to tell us the direction. So that means it's going to be what? 4 kilometer west. Everybody, if you understand this, give me a thumbs up. If you understand this, give me a thumbs up so that I'll move like the speed of light. Thank you, Rachel. Thank you, Anointed. Thank you, Justice. Lydian, are you still with us? Thank you, Stephen. Susan is giving me a thumbs down. All right, Susan, just a very quick one. Confidence is giving me a thumbs down. So, but you understand this one, because if you've not eaten, try and eat. You understand? Maybe it might not be what I'm explaining that is the problem. It might be your stomach. Your stomach might be a problem. So if you've not eaten, just save us this time now and eat something. Okay. So so let's review it again. Now we have positive here for north. South is negative. East is negative. I'll be very fast about that. So 3 kilometers to the west means -3, right? Why am I changing these signs again? I think I'm the one that needs to eat actually. So the west now is -3. The east is what? Positive, which is 4. Yes, and then 5 kilometers to the west, that's -5. So when I bring everything together, -3 minus 5, you're owing somebody. Susan, mute yourself, please. You're owing 3 naira. When you see negative, when you see negative, that means you're owing. You went ahead to borrow again. That's -8 plus 4. So that equal to -4. So displacement is what? 4 kilometer west. Susan, does it make sense now? Sister Susan, good. Sister Confidence, does it make sense now? If it doesn't make sense, just go and eat and then watch the recording later. Now, example 3, a car travels 10 kilometers to the east and then 15 kilometers to the west. What is the distance traveled? Now they are asking you distance. Distance just is about the magnitude. It has nothing to do with direction. So there's no need. What we are looking for is what total length traveled. So the distance right here, a very quick one. The distance is going to be equal to what? 10 plus 15. So nobody's asking you what the direction is going to be. So it's just the magnitude. So the distance is equal to what? 15 kilometer. All right. So that said, let's proceed to the next as fast as possible. So distance is equal to 15. Thanks for the thumbs up. All right. So the next one is that a body moves 6 meters to the east. Pay attention now. Remember our 4 cardinal points. Pay attention now. Pay attention. Even the guys that feel that you know that you've done these things already, but now pay attention to this one. Yeah, don't sleep off on this. A body moves 66 meters to the east and then 8 meters to the north. If you check, it's no longer traveling on a straight line, right? It moves to the north. First of all, moves to the east. So this is east. And it traveled what? 6 meters to the east. And then what the journey looks like, he now went ahead to move along this side. So observe that very well. So he moved to the east. This is my east direction, right? And then he moved to the north. This is my north. And that distance is what? This is what? 8 meter. Now, what is the magnitude of the displacement? Remember that this displacement is the shortest distance between 2 points. Shortest distance between, the shortest distance between, no. So you said 10 plus 15 equal 15. Is that what I said? Is that what I said, guys? I think we should go for commercial break so I can eat. And you guys kept quiet. Susan, thank you so much. Now I know that you're the only person that like me in this class. And this thing will go live. You'll be like, this guy is not, this guy don't know what they teach the children. Hey, my God. Sorry about that error, please. Sorry about this. So, and nobody said anything. Susan, one sachet of water for you. One sachet of water for you. Thank you. Even Titola did not say anything. And Rachel, you are here as well. You didn't say anything. All of you, and I hate me. Oh. So 10 plus 15 is equal to 15. That's amazing. All right, so let's go. So for this one, he traveled what? He traveled to this side, which is what? Your east direction. Remember, I had my 4 cardinal points just to give us a context of what we have, right? So here we have north, we have east as well. So distance traveled here is what? 6 meter. Then he went up to the north, and that was what? 8 meter. But remember displacement, shortest distance between the starting point and the ending point. So now the displacement now is going to be the distance from here to here. This distance here is now your displacement. You've seen that it has changed. This is your D, your displacement. It is no longer acting the straight line, no longer east to west or north to south. Now you're moving. And the angle between them now is what? Is 90 degrees. It is taking a different form. But you can link this to what we learned in vectors. Vectors can act perpendicular to each other. Vectors can be inclined to an angle. But sometimes, regarding displacement, they don't ask you for angles. They don't tell you about inclined at an angle other than 90 degrees. But sometimes it can come. In the lesson we did, we focused on force. Force was a vector. So when they are perpendicular to each other, we apply Pythagoras theorem. If you can remember those cases we did, when they are perpendicular to each other, when they are inclined at an angle, acute angle, obtuse angle. If you can remember, give me a thumbs up. Good. Give me a thumbs up. Any other person? Yes. Give me a thumbs up. Any other person? If you remember what we did on vectors, right? So that's the same thing I'm going to do here. So when they are perpendicular to each other, we are going to do what? Use the Pythagoras theorem. So what does that theorem say? Remember that in that class, we introduced and used our Pythagoras theorem. So which implies that when I have something like this, when I have this, right, and I have this as well. So what that simply entails that here, let's say here is C, here is A, here is B. So that C squared is equal to A squared plus what? B squared. So that's what I'm going to do. So I'm looking for what? My displacement, which is my D squared, will be equal to 8 squared plus what? 6 squared. Please be checking my calculations. There's high tendency. My next one, I'll say that 9 plus 10 is 41. It's possible because anything is, I don't understand what is happening. So 8 squared is 64. Confirm, is it 64 plus 36? So that D squared is equal to 64 plus 36. 6 to 9, 6 to 4 will give us 10. 0 carry 1. This is 100. Confirmed. So that D is equal to square root of 100. Right? So that at the end of the day, we'll have that our D is equal to what? 10 kilometer. Are you seeing it now? So displacement is what? 10 kilometer. Now, if they now ask you to find the direction, that is where some of us will now be confused how to get the direction. So the direction they are talking about at this point in time is now this angle here. That's what they're asking you for. The direction is this angle here. And remember your SOHCAHTOA, right? Remember your SOHCAHTOA, guys. Remember your SOHCAHTOA, guys. So for your SOHCAHTOA, you have SOHCA and SOHCA and your TOA. Now this time around, you have your, remember that the side facing this angle is your opposite, right? Why this side is your adjacent. So to find that direction, right, between them, what you're just going to do for us, you say that this is the magnitude. This is the magnitude. Now for the direction, my people, what we're going to do is just to the tan inverse. If you know you are lost, please, someone should find you. So that means that tan inverse, sorry, let me not go to tan inverse before they will start shouting. So we have that tan theta, which is direction, will be equal to the opposite over the adjacent, which is your tan. So 8 over 6. So that your theta will now be equal to tan inverse. But by the way, they will give you one that doesn't require you using calculator. So that theta is equal to this same thing as saying tan inverse of, when I reduce that guy to the lowest term, 8 over 6 is the same thing as 4 over 3. So tan inverse of 4 over 3. And 4 over 3 is 0.75. So check tan inverse of 0.75 for us. What will be the answer? Theta. Theta is equal to what? If I start waiting for you guys, I might sleep here. So let me look for my calculator. So tan inverse of 0.75, because I have 4 over 3. Is it 4 over 3? Yeah. So not 0.75. 4 over 3 cannot be 0.75. So shift tan, I have 4 divided by 3, close bracket. So that will give me 53. So the answer at that point is what? Is 53. So tan inverse here, that will give us 53 degrees. So D, the displacement, is equal to 10. And then the angle or the direction equal 53 degrees to the north. You take a reference there. Yeah, 50 degrees to the north. All right. So any question on that? Do you understand this? If you understand, can you please give us a thumbs up if you understand what I did here about the magnitude and what I did about the direction? Titola, are you giving me a thumbs down or a thumbs up? Titola, thumbs up or thumbs down? Thumbs down. So Titola, what's the challenge, please? Can you speak up? What's the challenge?
I don't understand the concept of everything in this
Okay,
number,
the
sha,
concept
but
of
the rest
the concept of everything.
say the concept.
Okay, the concepts. Okay. Have you eaten this morning?
Yes, I have.
Okay, okay. So you are qualified for me to explain for you. Now, a body moves. Look at what I'm saying. Have you watched the video we had on vectors when we did the resolution of vectors? Two vectors, Titiola. Titiola. Okay, good. So now look at what it entails. Look at what I'm saying. I'm simply saying that this time around, they are not moving east and west. If they're moving east and west, I'm going to use that direction because east and west are along the same straight line, east and west, right? So this one positive, this one negative. You bring them together to get the total displacement because displacement is simply shortest distance between 2 points, right? Sorry, yeah, the shortest distance between the starting point and the ending point. So that's what will give you the displacement. So now you started here. Look at where you started. You traveled to the east and then moved 8 meters to the north. So if you want to check shortest distance between the points you've traveled, which means distance from here through here to here, is just the distance from here. That will give you the answer, this side. And because they are perpendicular to each other at 90 degrees, you cannot do that same method we are doing for the other ones because those ones were just on a straight line. But now you've moved from east and entered north, or you've moved from west and entered south. So anytime you move, you're no longer moving a straight line. You now move straight line and you move downwards. That's a perpendicular line. And they make an angle of 90 degrees. So anytime it happens that way, that the movement forms a right angle triangle, they make a movement that are perpendicular, that means it's going to require you making use of Pythagoras theorem. But when they are acting along a straight line, maybe in the same direction or opposite direction, you make use of that thing we did, algebraic sum of both of them. But once there is a movement and it forms a perpendicular line, we have to make use of Pythagoras theorem so that we can get the displacement. Just like what we did when we did resolution of what? Two vectors. Some of them are perpendicular to each other. Some of them are inclined at an angle, acute angle, obtuse angle. So all of those things are things we treated when we did resolution of two vectors. Now, because I'm looking for this distance here, right? They are no longer acting in a straight line. And I said, here and here are known. I'm looking for this place. And what I can use to do that is your Pythagoras theorem. Is that also? And that's how I got my D. Now, the next thing you need to get is the direction. Unlike the other one, that the sign will tell you whether the direction is to the west or to the east or to the south or to the north if they are moving on a straight line. But here there's an angle between what the two places. So that angle here, more like this distance is your resultant vector. This D is your resultant vector, yes. And the vector you're talking about here is your displacement. So the resultant is D, and the quantity here is your displacement. So that angle is why I now apply tan inverse because I'm looking for the angle here. I have two sides of a right angle triangle. So tan will give me that angle here. Does that make sense now? Are you sure? You know, some persons there, you want to just have mercy on your teacher. The guy don't explain. You could be like, make I just tell this guy, yes, saying don't try. Are you sure you understood it? Okay. Sometimes we do that. Somebody will explain and explain. In your mind, you don't understand this thing. The person would you and you'll be like, yes, I understand. So that the guy no go say which kind of head be this. All right. So example 5 now. If a body moves from point A to point B and returns to A, what is the displacement? I go again. If a body moves from point A, that means that guy started from here, from point A, he moved to point B and still returned again to point A. Can someone attempt? What is the displacement? What do you think will be the displacement? I need someone that can think now, right? Someone that can think, someone that did not eat so much fufu this morning, that there's space in the brain to think. So a body moves from point A to point B and returns again to point A. What's the displacement? Anybody? Do you have anybody, or should I answer? Now, remember that, let's assume that, how do I put this? A is what? Justice. What did he say?
I said A is the displacement.
A is the displacement. Okay. Okay. Very close to it. It moves from point A to point B and returns back to point A again. What is the displacement? All right. Now the displacement is 0. Anytime you move from a point, remember that displacement is telling you the shortest distance between 2 points, right? The starting point and the ending point, right? So now, if I start from this place, I go to your house, and I still return back to my own house, my displacement is 0 because I've returned back from where I started from. Does it make sense now? So displacement is 0. That's why sometimes, some time ago, but I don't do that again. After traveling, I'll just come back to my status and be like, displacement equals 0. People will not understand. No, not most people understand, right? So displacement equals 0. That means I'm back to my location. Now, it doesn't matter how you did it. Let's say that when you left point A, let's say you went to point A, then you went to Chiamaka's house. You know, especially women. Let's say they went to go and buy something in the market. This is their house, but the place they want to go is the market here, right? So they first of all visited Chiamaka. Then from Chiamaka, they decided to buy PEF, right? And after that, they got to the market. Now, from the market, they will go to a spot to buy or maybe abacha and the rest of them to eat. Then this is where they stopped. Then they remembered that they need to visit another friend. Maybe let's say they want to visit I want a Yoruba name now. Or Titiola, visit Titiola. And after everything, she comes back home. So it doesn't matter how she navigates. The main thing is that she started from here and still came back to this point. So her displacement is equal to 0. Does it make sense? So these are the kind of questions you can see. I leave point A to point B. I'm back to the place I started from. My displacement is equal 0. Does that make sense? Are we on the same page now? A thumbs up if we're on the same page. Or rather, a love emoji, please. So that I can see love this morning. Thank you, thank you, thank you. I'm covered this week. I am loved by his message. Power. All right, so now let's continue. Good, good. So now, yeah, because I don't know when next I will see love emoji. Right, but I'm glad I saw it yesterday and I saw it. Wow, really? I don't know this secret. I I saw it yesterday and I saw it this morning. That means this week is going to be powerful, right? All right. So now, note if the movements are along the same straight line, you add them together algebraically. Get the signs, take note of the signs and add them together along the same straight line. So that straight lines can be north to south, east to west. Do you understand? So if it is along that straight line, just do what? Add together -4 plus this. Now, if the movements are perpendicular at 90 degrees to each other, you use what? Use Pythagoras what? Theorem. Do you understand it now? So when the movement is perpendicular, especially when you're moving from the east to the north, or anything that entails you leaving the straight line like this to go to another coordinate, that will make it perpendicular. But when you maintain the same coordinates, let's say the coordinate of what? If you are within east to west, the same straight line, west to east, the same straight line. Another straight line, let's say you're moving north to south, and then south to north again. That English. It's you see the same. I know you understand what I'm saying. You see the same straight line, right? So you just what take into account the sign. Here, up is going to be positive. Here is going to be negative. Then you bring them all together. Then just same principle will land during vector resolutions, finding resultant vector. So pretend as though you are finding the resultant vector. Go and watch that video on resolution of vectors. So if you are doing all of these things, what you are looking for is a resultant vector. That's a resultant what displacement. All right. That said, give me a thumbs up if you are all on the same page. So what you can do, go ahead and look for questions that has to do with displacement, that has to do with distance. Someone sent that question to me. I can't remember who that person is that asked me a question that has to do with displacement, and someone traveled 4 kilometers back to 5 kilometers. I can't remember, but someone sent that question. So check your past questions. Now, Emmanuel, remember we have a deal. You are going to get that past question for us today. So now we have speed and after the class, remind me. So speed and velocity. Now, speed is the rate of change of distance with time. Sometimes we confuse speed and velocity, but they are two different parameters, right? Speed is a scalar quantity. Speed is a scalar quantity and it has no direction. And it's always what? It is always what? Positive. Are we together? It is always what? Positive, right? That is for your what? Speed. So speed is what? Distance all over time. And it is a scalar quantity. It has no direction and it is always positive. Take note of that, guys. So the next key point here is your velocity. Velocity is the rate of change of displacement with what? With time, right? So this time around, velocity is a vector quantity. It has direction. It can be positive or negative because of what? You account for the direction, just like your displacement. But your speed is not a vector quantity, and you do not account for the displacement as the case might be, right? So it can be positive or negative. So look at this very question. I said, let's just think together. Let's think out of the box. Now, what happens when a body is moving in a circular path at a constant speed? A body is moving in a circular path, but the speed is constant. Let's say at 40 kilometers per hour. You're moving around a circle. So what happens when a body is moving what? In a circular path? Now, if you check, if you're moving in a circular path, if you're moving, if you're moving, someone is crying already. If you're moving in a circular path, right? You never even start phasing, you don't they cry. You're moving the circular path this way. Let's say you started from here. Then the next part, you are now here. And after some time, you are now here. And finally, you are now here. Are we together now? Can't see the video. Who again cannot see the video? Okay, you can see it now. All right. Maybe your network entered 2G. So now the next thing here, that's the movement along the circle, right? So they said, what happens when a body is moving in a circular path at a constant speed? In as much as the speed is not changing, but you can see that you are changing your direction. Is that not so? Direction is changing. Your direction is changing. And because your direction is changing, we can see that what? The velocity is changing as well. So what happens? What happens when a body is moving in a circular path is that the speed will be constant, like they said, but the velocity will be changing. I'm just trying to tell you that there's a difference between speed and velocity. You can see that the speed is constant. Let's say 30 kilometers per hour, moving through this circle at 30 kilometers per hour. This person is traveling at what? 30 kilometers per hour. That is the speed at constant. Nothing is changing. But now, since I'm moving around the same speed, when I mean 30 kilometers per hour, let's say that you are driving a car. Just assume that you are driving a car. Assume. Now, and I know why I say you should assume. And that car that you are driving, if you check that speedometer, the you are matching your throttle, but at a constant pace. Like you stayed at a particular point. You are not increasing your speed. You are not matching the throttle so much. You are not moving back so much as well. Just at a constant speed, right? So that is 30 kilometers. So on that speedometer, that circle thing there on the dashboard is reading 30 constantly. But then because you are moving through a circular path, your direction is changing. And because of that, velocity is changing as well. If you understood what I said, give me a thumbs up. Give me a thumbs up. Suzanne. Is it thumbs down? You don't understand what I'm saying? So anybody that understood what I said? Justice. Okay. At least. Okay. Okay. Mesoma. Okay. Plenty person don't understand. Okay. Let me explain again. So I explain again. Oh. Okay. Now look at what I said. Speed is constant. Right? Imagine you are riding a bicycle. Let's use that bicycle one. You are riding a bicycle. You are not matching I wanted to say throttle. You're not matching the pedal so quick, just small. The same rate, you are matching the pedal at the same rate. But that same rate you are matching it, you are trying to rotate, you are traveling through a circle. Like that time, you people might not know, that we used to pay for hire. Like you pay, how will I put this? When you there's a particular field back then, you pay them so that when you go round the field, you pay 20 naira back then. Go around again, you pay 15 naira. And that's how we spent the money. I didn't say that. This call is recorded. So as you're going around that circle, you are changing your direction. Your direction is changing. But the same way you are matching the pedal is not changing. That same rate, you are matching it that way. Your speed is constant. But because of the fact that you are changing direction, you are moving around the circle. And because of that around the circle, your position is changing. Your direction is changing. Your position is changing. Because of that position and change of direction, we say that the velocity is changing as well. Because what is velocity? Velocity has to do with what? Displacement over what? Over time. And why am I saying all of these things? I'm saying this just to let you know that there's a difference between speed and velocity. Speed can be constant while your velocity is changing. And velocity is a result of what? Change in position. Change in position, change in direction. That brings about what? Your change in velocity. Oya Titiola, go ahead.
My question is that you said speed can be constant, but me, I don't know. I feel like can't speed change?
Yes, speed can change. Speed can change. Like if you watch your Fast and Furious, you will see what is happening there. That place, speed is not even changing. The speed is transforming. So speed can change. Even velocity can change. Like I said, speed can change. But I'm trying to say that it's also possible that you are traveling at a constant speed. Like you are running, you are not running too fast, you are not running so slow. You are maintaining the same pace gradually. It's a constant speed. But you can also decide to run very fast. Your speed has changed. Do you get the point? Another example, when you are in a traffic jam, your speed will reduce. You'll be traveling gradually. After the traffic jam, what happens? You speed up again. Your speed changes. But I'm trying to tell you the fact that the difference between speed and velocity, that it's possible that speed might not be changing, but velocity is changing. Does it make sense now? Good. Chino, so you're a good guy. It be like say you don't do driver work for so many years. It's more like what you are driving and then you are trying to take a turn. Because of that turn you are taking, your velocity is changing because velocity is a function of your direction. But speed is just there. Speed, you're not accounting for direction for speed. Speed is about how fast and how slow. Titola, do you understand what I'm saying? Good. Dear Lord, grant them understanding in Jesus' name. Grant them understanding. Your eyes are open. Your ears are made open. Yes. So everybody now will understand, right? We understand now, right? Good. Everybody on the same page. Yes. All right. All right. Makes sense. Now let's look at velocity and acceleration, right? So acceleration is the rate of change of velocity with time. Acceleration is the what? Rate of change of velocity with time. So your velocity is changing with what? With time. And when velocity is changing, remember that what? Direction is changing. So that is the key reason why velocity is a vector quantity, because it has to do with direction. But speed is just a scalar quantity, just the magnitude. You move very fast, you move very slow. Whether you move to the right or to the left, I don't care. My own is that this person is moving very fast, or this person is moving very slow. But whether right, left, forward, backward, we don't care. That's why it is what? A scalar quantity. Now look at acceleration. Change in velocity over time. So now, what happens? So note that acceleration occurs when, number one, speed changes. These are three things that can happen. You say that the acceleration is changing. So now, if acceleration has occurred, so if I'm increasing, if I'm riding a vehicle now, sorry, how can you ride a vehicle, bro? If I'm driving a vehicle now, right? Now, the speed can change. And as I'm changing that speed, maybe very fast, very slow, my acceleration, something is happening to acceleration. Do you get the point now? So speed changes, acceleration will occur when speed changes, whether fast or slow, or direction changes. What am I trying to say? My speed might be constant, but because I've changed to the left, it means that acceleration, something is also happening to the acceleration. So it's possible for speed to stay constant, but acceleration is changing. It is also possible that my velocity will stay constant. That means I'm not changing direction, but I'm driving very fast. Also, acceleration is changing at that point. So acceleration occurs when speed changes, direction changes, or both speed and direction changes. So these are some of those things that will happen. I will say that acceleration is changing, or acceleration is occurring. I don't think that word occur, but I just have to put it there so that we can capture it, right? So that is your acceleration. All of these things will make sense when you start solving problems in motion. Nobody has broke down this kind of thing so we understand. So most times we are cramming, but if you understand all of these things, that speed can change, yes, acceleration will change as well. Speed can be constant, but because my direction is changing, acceleration is also changing. It's also possible that my velocity is constant, which means my direction is not changing, but I'm moving fast in speed, I'm moving slow. Acceleration is also what changing. Give me a thumbs up now if you understood what I said. A thumbs up if you understood what I said. Also thumbs up. Richard, thumbs up. Thumbs up. Susan, thumbs up. Confidence, thumbs up. Okay. Stephanie, what am I trying to say? Stephanie, we are trying to say that a very quick one, that acceleration is a function of two things. Acceleration is a function of speed and a function of velocity. And velocity, that is direction. That I can be running so fast. As I'm running so fast, my acceleration is changing as I'm running fast. And as I'm running fast, what happens? Acceleration is what is increasing. I'm accelerating, I'm running so fast. If I'm running very slow, my acceleration is doing what? Is reducing. Is that not so? Reducing. I'm not running fast. So that is what? Speed. And I'm only looking at fast and slow affecting acceleration. But let's say that I'm not changing direction. I'm just running. I'm going forward, just straight up. I'm running in a straight line. I'm not running to the left or right. I'm just running straight up, which means my what? My direction is still the same thing. It has not changed, but speed is changing. And because of that, acceleration is changing. It's also possible that I am running. As I'm running, I'm going to somebody's house. I get to the left part. I take my left. I keep running. The next part is the right hand side. I run to the right. I'm still running. So what is happening? Acceleration is occurring as I'm changing my speed. I'm changing my direction. But there's tendencies that I am maintaining a constant speed. Like I'm running. I'm not running fast. I'm not running slow, right? But I'm changing my direction. It also means that acceleration has occurred. Does it make sense now? Ibaja, Stephanie. All right, beautiful. That said, we can move. Give me that love emoji, I beg. Next one, please. Thank you. So, example one, right? A car moves at a constant speed round a circular track. A car moves at constant speed round a circular track. What does it mean by this constant speed? It means that it is not running fast, it's not running slow, it is maintaining a particular pace and is moving around a circular track. So which statement is correct? The first one says its acceleration is zero. Its velocity is constant. Its acceleration is directed towards the center. Its displacement is zero at all times. So let's look at them one after the other. They said the first one, acceleration is zero. No, acceleration cannot be zero. Why can't it be zero? Can someone give me a reason why it cannot be zero? Anybody that can give us a reason why it cannot be zero? Anybody giving me a reason why it cannot be zero? Because what? Yeah, somebody said because velocity is changing. Thank you. Right? And not just velocity changing, the direction is changing. And if direction is changing, velocity is changing. Thank you, Emmanuel. Right? And I said, yeah, it is changing. So if you see, I'm moving around a circular track, like I said before. I drew that circular track. Your speed is constant, but you're moving, your distance are changing. Direction is changing, so velocity is changing. And we said that acceleration occurs when either the velocity is changing, or the speed is changing, or both of them is changing. So there's tendency that speed might not be changing, but if velocity is changing, that means acceleration is changing. If both of them are constant now, if speed is not changing, velocity is not changing, that is when we now say that acceleration is equal to 0. So this one is off. Velocity is constant. No, you're moving around the circular path, so it cannot be constant. So acceleration is directed towards the center. Yes, you're moving around the circle, right? So E displacement is 0 at all times. Does that make sense, guys? Do you understand why C is the answer? Yeah, thank you, Justice. Thank you, Rachel. Susan, Titiola, Titi, Anola, Shedrack Muto, okay?
Titi Lola, not Titi Ola.
Titiola,
Or you can say
Titi Loladi. Did you understand what I said?
Yes.
Okay, well done. All right, let's continue. That kind of voice. But when you are hungry, is that how you talk? I doubt. Example, if someone eats your food, you come back to the house and the food they kept for you, someone have eaten the food. Will you? Is that how you will sound? Who ate my food? You're not serious. All right, let's continue. Titi, don't mind me. All right, so let me explain again. So you have a circle right here, right? And they said that a car moves at constant speed round a circular track. So which statement is correct? For the fact that it's moving around a circular track, if you're moving around a circle, is your position not changing? When you're moving around a circle, is your position not changing? Titola, another person that said no. Is your position not changing? Give me a thumbs up. If you're moving around a circle, your position is changing. Is that also? Yes, it's changing as you're moving around a circle. So now, and I said that if your direction is changing, it means your velocity is changing. More like, okay. You cannot be married and single at the same time. Do you get the point now? You cannot be married and single at the same time. So which means that if your position is changing, it means that, yes, your velocity is changing. So if you are not single, it means that you are married. Or you are engaged. Or maybe, I don't know. But I'm just trying to use an example we can relate with. So once your direction is changing, it means your velocity is changing. And we said something that for us to say that acceleration is changing, there are two variables. Let me create a new slide here. So there are two variables that must be present. So now let's say that this is acceleration. Acceleration is dependent on two things. The first one is what? Speed. The second one is direction. So if this one is present, it means that acceleration still works, even if this one is absent. Do you get the point? So if one of them is example again, back then in secondary school, if your father attended PTA meeting and your mom did not attend, would they say that your family did not attend? Would they say that? If they do that, then something is wrong with them. Do you get the point now? So if your father came, even if it's not your parents, maybe your brother or someone came from your family, you are represented. That's the same thing here. So speed and direction, this is your PTA meeting. So speed and direction are the family that should come for the PTA meeting. So if direction is present, and remember that direction has to do with what? Direction has to do with what? Velocity. So if direction is present, it means that yes, I was in the PTA meeting, even if speed is not present. Now, if speed is not, if your dad is not around, your mom is around, it also means the acceleration is working. So, and speed simply means how fast or how slow something is moving. Are you seeing it now? How fast or how slow? Or if you're just moving at a particular pace, like you're not moving fast, you're not moving slow, you're just in between. Now, direction simply means you are changing your position. And if you are changing position, velocity is changing. That said, apply it to this very question now. They said that the speed is constant, which means speed is not changing. Speed is just that way. That means speed is not present. Do you get the point now? But now something is happening. You are moving around a circular path. So because you're moving around the circular path, your velocity and direction is changing. So velocity is changing. Therefore, acceleration is present. Does it make sense now? I don't know how else to explain, but I think that PTA meeting should make it clearer. Is that okay now? Who gave me thumbs down before? Who gave me a thumbs down before? Abi, you give me thumbs down, come out. Who was that? Okay, Susan, go ahead. Sister. Okay, not Susan, Shedrack. Shedrack Moto. Power. Go ahead. Shedrack, your hands are up. Turn on your mic and ask your question so we can move. Shedrack, are you a road safety? Maybe you are telling me stop. I'll be asking questions. So let me proceed since you're not saying anything. Okay. Any other person that is still confused? People that said they didn't understand before now. Can you give me a thumbs up, everybody, now if you are following? Can I move? Let's move, guys. Good. Other persons in call, let's move. Thank you. Now, the next one says, which of the following? I want your answers in the comment section. Everybody. Which of the following situations involves zero acceleration? Send your answers on the chat. Zero acceleration now. Send your answers on the chat. Let's pick the correct answer. Which of the following situations involves zero acceleration? I want to see your answers in the chat. Let me go to the chat now. I want to see your answers in the chat. Sorry, send your answers again. I stepped out. The network logged me out. Okay. Justice said B. Confidence C. Okay. A. Answer na water. Yeah. Jewe me. Okay. I have Lillian B. Paul B. Isiola B. Titilola. Okay, Titilola D. Shedrack A. B. Confidence C. Justice B. Susan. I've not seen your own answer, Rachel. Rachel, I'm yet to see your own answer. Mesoma Gift, have you sent your own answer? Rachel, your own answer. Mesoma Gift, your own answer. D. Good. Rachel, what is your own answer? All right, so let's see. They said, which of the following situations involve zero acceleration? So zero acceleration. Acceleration, nothing is happening. So the first one, a car moving with a constant speed in a circle. Now, since they've highlighted in a circle, are we there? So since they've highlighted in a circle, for the fact they said in a circle, right? For the fact they said in a circle, it means that in as much as the speed is constant, right? Speed is not changing. But since they said in a circle, it means that acceleration is changing. Because in a circle means that direction is what is changing. So people that picked A, you are wrong, right? So how many of you chose A? How many persons chose A? Let me see the charts. How many human beings chose A? Okay, Shedrack A. Susan A. Okay, it's fine. Freedom of choice. But choose the right thing. Well done, guys. I'm proud of you guys. So this one is off. A body moving with constant velocity in a straight line. A body moving with constant velocity in a straight line. Let's come back to that. A stone thrown vertically upwards. So when you are throwing something upwards, you know that initially it will move with a bit force and then keep reducing. So that place, something is changing. So here we are off here. A car slowing down. If you are slowing down, it means that your speed, your speed is decreasing, which means that something is happening. Acceleration is changing. If you are throwing something vertically, you are also moving. Speed is changing, and therefore here speed changing. Sorry, here speed is changing. That means if speed is changing, that means that what happens? If our speed is changing, that means that what happens? Acceleration is happening. So speed changing. Here as well, speed is changing. But you see here, moving with a constant velocity. If I'm moving with a constant velocity, what does that mean? It means that the velocity is not what? Changing, constant. And if I'm moving in a straight line, what does that tell you? It also means that the speed is constant. Are we together now? Constant velocity in a straight line, right? They didn't say anything about the speed actually. So in a straight line means speed is not constant. Constant velocity means velocity is not changing. And in a straight line means you're not changing your direction. Do you understand now? So once I'm not changing direction, it means that, oh yes, that what happened, that acceleration is changing. Sorry, acceleration is constant, I mean to say, right? Acceleration is 0. You're not changing direction, you're not changing your velocity. So that means that in that situation, you have 0 acceleration. Does that make sense? Because in this place now, you have that in as much as the speed is constant, yes, but here, velocity is changing. So people that said B, send your love emoji. Let me just love emoji. Those ones that chose B, just justice so yeah. Well done. Good, Lillian. Good. Other persons, do you understand it now? Other persons, do you understand it now? Okay, thank you, Susan. Thank you, Stephanie. Please, is someone still on this? There's someone I'm looking for on the call. I don't think she's still here. Yeah. Richard, are you still here at all? Ensure you are following, please. Ensure you are following. All right. So the next one is types of motion. So we can go to other things. This is definition. So just know it. So we have translational motion. Translational motion has to do with movements from one place to another. Is that not so? So I don't understand the math class. This person class is going on and you're saying you don't understand math class. I'm coming. All right, so we have translational motion, and we have translational means you're moving from one point to another. That's translational motion. So when you're moving, let's say you're moving from here to your house, from here to somebody's house, that's what translational. You're making a movement from A to B, from B to C. You're changing you're moving. Vehicle moving from one point to another, that's translational motion, right? So movement of a car, movement of human beings is translational. Next one is rotational motion. Motion about a fixed axis, moving in a circle, right? Example is your fan that is rotating. Yeah. Even your vehicle, the tire of your vehicle is also rotational motion. The next one is oscillatory motion. So that is what? Back and forth motion about a fixed point. Example is your simple pendulum. That experiment you did back in school. You guys will be counting it. 1, it goes front, goes back, comes back again, just that way. That's your simple pendulum. Another example is that your swing, that someone will push you. I think that's a very risky, one of the most swing that will also always cause injury in school. In my primary school back then, they had to remove it entirely. That one you enter, someone will push you front, back, and some persons that are very wicked will take that thing very high and then leave you to flip. That's why some schools have removed it. So that thing is what? Oscillatory what? Motion. Do you understand? The random motion is irregular, just like smoke, right? So that's for that. So take note of this. They can ask the questions sometimes. So some questions that they can ask, they said the motion of the membrane of a drum when it is beating, that their drum, as you are beating it, is an oscillatory what? Motion. So right there is what? Oscillatory, right? It's an oscillatory motion. It involves back and forth. So now example 2 says, which of the following? So example 2 now, who answers that one for us? Let's see your answers. Which of the following involves both translational and rotational? Which one involves both translational and rotational? My eyes are on the charts to see our responses. All right, go ahead. I keep going out. So have you sent your answers, please? All right. Okay. Titiola said B. Who again? B. How many persons said B? Okay, Stephanie said B. All right. Who again? Confidence said B. Who again? Susan said B. Justice said B. Okay, the B has it. Okay, why? This one, if you throw a stone vertically upward, so this is more like you're changing position. That's translation now. A vehicle moving, a rolling wheel moving forward. Now, there are two things. The vehicle is rolling, which is what? Rotational. And the wheel is also moving forward from one point to another. So that makes it what? Translational and rotational. Vibrating, turning for, that means to and fro. That's oscillatory motion. A swinging pendulum, that's also what? Oscillatory motion. So take note of that. So I now said, check for past questions on speed, velocity, acceleration, displacement, distance, and types of motion. That's your work. Go and check for it. So that's the bed you need to buy so you can enjoy your marriage. All right, thank you. Next one, please. If you followed up to this point, give us a thumbs up. Let's know you're following, please. All right, so well done, Stephanie. Awesome. So now let's continue. Equations of motion. Equations of what? Equations of what? Motion. So these equations apply only when acceleration is constant. What did I say? These equations apply only when the acceleration is what? Constant. If acceleration is not constant, don't use this formula or these equations. If you use that equation, you are on your own, and I did not teach you. God knows. So these equations can only be used when what? The acceleration is what? Is constant. Now, note, these are the common phrases that indicate constant acceleration. These are the kind of phrases you're going to see. And you know that that question is a constant acceleration question, right? Just like the kind of phrases you are going to hear, and you know that, okay, let me not say that. But I know you know what I want to say, but let me not say it. So there are some phrases you are going to hear, you know that, yes, that something good is happening, right? Yeah. So there are phrases you are going to see, you know that someone wants to bill you, right? Once you see that sentence, the person have not even said it, but once you see that very phrase like this, you know that, yes, this person won't bill me. So that's the same thing here, that once you see some of these things, you know that, yes, that this is a question that has to do with what? Equations of motion. Number one, if you hear anything about uniform acceleration, if you hear that it starts from rest, if you hear retarded uniformly, if you hear decelerates uniformly, if you hear freely falling body, like it's falling from a height, or the rest of them, if you hear that something is thrown vertically upwards, so these are the phrases they are going to see, and you know that that very question is an equation of motion question. Are you guys writing at all, or you're looking at the slide? Are we writing? If you know you're writing, give me a thumbs up. Okay. Titiola, I know your brain is computer. You're not writing. Mesh, are you writing? Mesh, you're not writing. Why? People should be writing. I don't know what you don't depend on the slide, because there are some things I say that are not on the slide. You have to put them down so you can always remember, right? Write your note. That's why you're in a class. Okay, went somewhere. Lillian, are you writing? Lillian, are you writing? Why are you not writing? You're just watching it. You're watching a movie. Eh? You're watching a movie. Okay. Oh. You're watching Atalugo, are you? So now, so if acceleration is changing, these equations do not apply. So these are the equations of motion. There are four of them. 1, 2, 3, 4. So it's expected that at this age, at this your age in life, as a science student that you are at this point in life, you should know these formulas offhand, right? It should be like your second name. You should know them and remember them, right? So these are the equations of motion. So how do we apply this equation of motion? There's a shortcut that we normally use or a trick that we use to remember these equations. But before then, let's look at something very important. Now, we make use of what I call the SOVAT method. Now, SUVAT, SOVAT, right? So where S means displacement or your distance, U is the initial velocity, V is the final velocity, A is acceleration, and T is what? Time. And look at these key things I want you to take note of. These are like the parameters. Rachel, are you still on this call? These are the parameters I want you to take note of. There are 5 arms of that. So these are the 5 arms I want you to take note of, right? It might be less than 5 about some of the things I want to say, but these are the rules I want you to take note of. Remember this SOVAT method, SUVAT, SOVAT. Displacement, initial velocity, final velocity, acceleration, and time. So now, every equation of motion, right? Take note of this. Every equation of motion contains 4 of these 5 variables. There are 5 of them. So every of those equations contains 4. So in that case, one of them is missing one of it, right? You cannot have 5 of that variable. So all those 4 equations, they have 4 of these variables. None of them have the 5 of them. So those 4 equations, we only have 4 of those variables, and then we'll be lacking one of them. Do you understand what I just said? Give me a thumbs up if you understood what I just said. To be lacking one of them. A thumbs up if you understood what I said. Yeah, so those variables will always lack one of them. Okay, Susan, look at what I'm saying. There are 5 of them. 1, 2, 3, 4, 5. So far, these are the 5 variables that we'll be looking for using the equations of motion. Now, these 4 equations, each of these 4 equations will contain 4 of them. Look at it. How many variables are there? V is here 1, U is here 2, A is here 3, T is here 4, which means 1 is missing. Let's count this one. S is here 1, U is here 2, T is here 3, A is here 4. T is the same thing. 4 of them. Look at this one. V is here 1, U is here 2, A is here 3, S is here 4. So all of them contains 4 of those variables. But one of them will be missing in all of them. You understand? It's either T is missing in your own, or A is missing, or this one is missing. You can only have 4 of those variables. Look at this one. S is 1, U 2, 3, and 4. Do you understand it now? So that's why we have this SOVAT. Always remember that this SOVAT, there are 5 of them, but the equations can only contain 4, and one of them will always be missing. Give me the thumbs up now if you understood what I said. All right, I think everybody on the same page. So let's continue. So these are the things I want you to always remember. Now, how to use the equation. I'm going to come back to this equation. If you have a particular question, you want to solve a particular question, choose the equation that does not contain the missing variable. For example, they give you a particular question. They will say something about time. They will always say something about 4 of them. They will say something about 4 of them, and one will be missing. They can say time is this, velocity is this, final velocity is this, find U, which means they've talked something about 4 of them. Even if you are finding U, it makes it number 4. So, but one of them will not be mentioned at all. You're not finding that one. That one is not given, right? It means that use the equation that does not contain that one. I go again. The trick to selecting sometimes we are confused when they ask you a question on motion. You're asking yourself, which one should I use, right? So the one you're going to use is the one that the variable is missing in it, right? So for example, they can give you the time, they give you the initial velocity U, they give you final velocity U, and they ask you to calculate the distance. That is 4 variables. Even the one you're calculating makes it 4. It will always be 4. Now, the equation you're going to use is the equation that does not contain that one that was not mentioned. The equation that does not contain that one that was not mentioned is what you're going to use in calculating it. Do you understand what I just said? Do you understand what I just said? A thumbs up if you do. Okay, good. So when I solve questions, you're going to understand it better. So now look at the variables I want you to always remember. When the body starts from rest, U is equal to 0. These are the rules and regulations. When a body starts from rest, it means that initial velocity, remember that this is initial velocity. When you start from rest, Rachel, did you step out? It seems you stepped out. This is initial velocity. Now, when a body comes to rest, it means that final velocity is 0. Take note of those things. Now, the next part, for a free fall, you are falling freely from a height or something. So that is when object falls. The acceleration at that point is 10 meters per second. Even if they don't give you, just know that for a free fall, acceleration is what? 10 meters per second. These are the rules I want you to always remember. And for that free fall, u is equal to 0. Initial velocity is always equal to 0 for a free fall. Even if they don't say it, once you hear free fall, it means that the initial velocity there is equal to 0 and acceleration will be 10, which means for a question that has to do with free fall, 2 variables have been given already. Remember that when a body is brought to rest, v is equal to 0. Now, if an object is thrown upward, if I throw an object up, the final velocity v is equal to what? 0, right? So these are the key things I want you to remember. Remember, this is your initial velocity. Everybody, do you understand? Initial velocity, and then this is your final velocity. So these are the 4 rules I want you to remember anytime you are solving motion problem. Just know them. They are the things you need to know. The way you know your surname, right? Just know them as you know your surname. Just know them as you know how to cook, how to boil hot water. It's very important. Let me not say how to cook, because I know some persons they might not really know how to do that. People like, I'm very good, don't worry. I'm a very brutal cook. The only challenge is that when I cook, they should ensure that they have water in the house for them to visit somewhere. You understand? So that's the only thing. As I'm cooking, they're making sure that there's enough water in the house for them to take care of themselves when something begins to happen in the stomach. So now, example 1, a car starts from rest and accelerates uniformly at 4 meters per second for 6 seconds. Find its final velocity. Now, check the variables that are present. A car starts from rest. If it starts from rest, it means that u is equal to 0, right? So u is present, u equals 0, and accelerates uniformly at 4 meters per second squared. Are you seeing it now? Acceleration is meter per second squared. Velocity is meter per second. Take note. I didn't put that in your slide, but take note. Meter per second squared is acceleration. So now at 4 meters per second squared, that means acceleration is present. For 6 seconds, time is present. Find its final velocity. They want us to find v. So now 4 variables are present. Hence, we apply the formula that does not contain s. To solve that question now, the one that doesn't contain s is what I'm going to use. So which formula is that does not contain s? You're going to see that the one that does not contain s is what? Equation number 1. V is equal to u plus 80. Very simple. That's how to know the equation to use. Just check the variables that are present. Even the one you are asked to find is also a variable and is present. You assume that it's present. Do you get the point? Oh, Stephanie's giving me a thumbs down. Oh, dear Lord, grant Stephanie understanding. Open her eyes to see that she may understand this. Remove every veil on her eyes. Amen. All right, so look at what I'm saying. Now, Stephanie, I said that a car starts from rest and accelerates uniformly at 4 meters per second. Now, I said that how to know the formula to use. Are we together? How to know the formula to use is that you take the variables that are present. Remember we said that 4 variables must always be present. 4 of those variables must always be present in a particular equation. But one of them will be missing. So you check for a particular question. What are those 4 variables that are present? Take note of them. Now, which one is not present? That one that nothing was said about it. Look for an equation that doesn't have it. Use that very equation. I go again. There are 5 variables, solvers. Every equation contains 4 of those solvers variables, right? And when a question is given, take note of those variables that were given to you and check for an equation that does not contain that one that was given to you, that was not given to you. For example, a car starts from rest. It means that what? V, u is equal to 0, starts from rest. Now, accelerates uniformly, it means that a is equal to 4 meters per second. For 6 seconds, it means that for 6 seconds means that t is equal to 6 seconds. Find its final velocity. We don't know V, but it was mentioned. So that's to say that 4 variables are present. So which variable was not mentioned, Stephanie? There was a variable that was not mentioned. Which variable is that?
S.
Good. So S was not mentioned. So look for the equation that does not contain S. That's the equation you're going to use. Otikile Naba? Okay, thank you. So that equation that does not contain S is what? And that equation that does not contain S, sorry, the equation that does not contain X is what? V equal to U plus AT. So we are looking for V. So U is 0, started from rest, plus 6, sorry, plus A, which is 4, times by 6. So that V is equal to 24 meter per second. So that's our velocity. Everybody, we are on the same page, right? All right, makes sense. So that's how to solve. So it means that our final velocity for this question, thank you, Shedrack. So final velocity, thank you guys. Thank you. Thank you. So it means that final velocity is equal to 24 meter per second. All right, second question. Second example said a body moving at 15 meter per second is brought to rest. When it's brought to rest, what does that tell you? That V is equal to 0. Final velocity is 0. To rest uniformly in 3 seconds. T is what? Is given. Find this acceleration. Acceleration was mentioned. So what are the variables mentioned here? U was mentioned, moving at what? 15 meter per second. So that is U. It was mentioned. Brought to rest. When you hear brought to rest, it means that V is equal to 0. V was mentioned. Uniformly in 3 seconds, T was mentioned. Find the acceleration, A was mentioned. So we're going to use the equation that does not contain S. Titila, why are you laughing? Eh? Can you tell me why you're laughing? What's amusing you? Eh? Titola? Titilola? Eh? Okay, now. Oh, the cleanup is so fast. What's the cleanup? Stephanie, what's the problem, please? I want to carry along now. Am I so fast? Am I talking so fast?
No, like I was writing the notes, but this Wi-Fi.
Oh, sorry. Sorry. In Igbo language, sorry, one ibem. All right, so a body moving at 15 meters per second. Titilola, how do you say my fellow woman in your language?
Let me try.
Okay, don't worry. You are those ones that learnt your language with
No,
English. Don't worry.
no, I can say it. I can say it.
Oh, yeah, say it then.
Obìnrin ẹgbẹ́ mi.
Thank God. All glory to God. All glory to Jesus. All right. I wish I got that very well. I wanted to say it as well, like one even, like my fellow woman. I want to speak that in Yoruba as well. Right. Okay. But I'm not a woman anyway. All right. So, sorry about that, Stephanie, for wiping so fast. So a body moving at 15 meters per second is brought to rest. Stephanie, you want to ask question? Okay. Is brought to rest uniformly in 3 seconds. Find the acceleration. So we are going to see that X was not given, right? So you have a question to ask? Okay, go ahead and ask your question, please.
Yes, I was asking how I can complete the note.
Okay, the note. What was cleaned before? What did I clean?
Like, let me just say from that displacement side.
Okay, displacement, that upper part.
Yes.
Hey, and I've cleaned a lot of things there. Did I clean everything?
Most of them, sure.
Yeah. But some of them are still there.
Eh.
Don't worry. Okay, don't worry. I'm sending this note to the class, to the group chat immediately after now. You are going to receive the notes.
Okay. Thank you, sir.
Yeah, but you're welcome. But next time I'm going to be take it gradually. You can copy something down. Sorry about that. I realized I was not giving time for us to copy. Yeah, next time I'm going to give time for that. So I can also breathe small, you know. So that's more food I eat will stay in my stomach. All right. So now remember the cheat here. So S was not given. So which equation does not contain S? That one that does not contain S is what? V equal U plus 80. So I don't know how all of them are revolving around V equal to U plus 80. So V is equal to what? They gave us okay, let me write down the variables they gave us first. A body moving at 15 meters per second. That means that V is equal to is brought to rest at 0. U is equal 15 meter per second. Our T, I prefer writing horizontal vertically. So T is 3 seconds. T equal to 3 seconds. Acceleration is what we are looking for. So we're going to apply that V is equal to U plus 80. So we have 0 is equal to 15 plus 35 times A. So that this will give us 0 equal 15 plus 35A. Are we together, my people? Are we together, my people? All right. So this is just normal mathematics. So I'm going to have that minus 35A is equal to 15, right? So let's divide both sides by, yeah? Is the time 35 or 3 seconds? I said it. Wow. Don't make this kind of mistake in exam hall. Don't do like me. You will fail waiting no good. So this is 3 A. So this is 3A. So this is minus 15 is equal to 3A. So we divide both sides. Justice, are you still here? Justice. Okay. Anointed. Have you gone for anointing service? Are you still here? Anointed. Are you still on the call? Okay, I think he has gone for anointing service, like I said. All right. So let's divide both sides. So 3 will cancel. 3 will cancel. So that A is equal to what? Minus 5 meter per second. Do you know what it means? It means that remember that it was brought to rest. That means that it is decelerating. When you have a negative sign, it simply implies that it is what? It is what? Decelerating. What did I say? It is what? Decelerating. That's why we have a negative sign right there. Right? So it's decelerating. So therefore, deceleration, you can remove this negative sign and say that deceleration is equal to 5 meter per second. So that negative sign already have actually
Minus
indicated
5.
that it is, yeah. So that minus 5 already is telling you that it's deceleration, right? Good. I think this is covering everything. So let's leave it like this. So the next one, example number 3, it says that a train moving at 20 meters per second accelerates uniformly at 2 meters per second. How far does it travel in 5 seconds, right? A train moving at a 20 meters per second accelerates uniformly at 2 meters per second, right? How far does it travel in 5 seconds? What are the information given to us? They gave us 20 meters per second, accelerates uniformly. So they gave us U. It traveled 20 meters per second. So it started from U, accelerates uniformly. They gave us A, 2 meters per second. They gave us the time, and they're asking us how far does it travel. It means they gave us S. So if I'm to put down the variables that was given to us, they gave me that my U is equal to 20 meters per second. They gave me that my acceleration is equal to 2 meters per second. They gave me that my time is equal to 5, and they give me 5 seconds. They gave me S. Okay, I'm looking for S, which means that 5 of the variables we are given. S was given, U was given, A was given, T was given, but V was not given. So what am I expected to do? I will check for the equation that does not contain what? V. That's the equation I'm going to what? Use. So which equation does not contain V? The one that does not contain V is the second one. So I'm using the second one that does not contain V. S equal to UT plus half AT squared. So that means that I have the equation S equal ut plus half a t squared. So x is equal to, the value of u is 20 multiplied by 2 plus 1 over 2 multiplied by a is 2 times by 5 squared. Are we following, guys? So that means that the value of my s is equal to 40 plus, this can cancel.
Now, I have a question.
Oh, go ahead, my bro.
You said 20 times 2, but time is given as 5.
Okay. What was given as 5?
The time, 5 seconds.
The time. They gave us acceleration. That's a sign. We need to go for commercial break so I can help my stomach. My stomach needs to consume 1 or 2. So this is 100. Thank you, Justice, for that. So plus, we're going to cancel out something here. Others, are we following? Hope we spotted that error as well. So now, thank you, Rachel. So plus 25. So that x is equal to what? X equal to 125 meter. So that the distance, thank you for that, my bro. That's justice. Blessings. Distance equal 15 meter. Any question around this? Any question, everybody? If there's no question, give me a thumbs up. No question, give me a thumbs up. All right. Everybody, Justice, you're giving me a thumbs down.
So I want to know
Hey.
how you divided through
Eh?
to get 25. How you divided through to get 25?
Okay. Now, you remember that U is 20, right? T is 5. A is 2 meters per second. And the time is 5 seconds. So, right, I have 1 over 2 times 5 squared. So 2 will cancel 2 to give me 1. 5 squared is 25. So 100 plus 25 will give us 125. Does that make sense? Yeah, Susan said her network is misbehaving. That network will stop misbehaving now. I speak over that network to stop misbehaving. All right, Stephanie, over to you. Go ahead.
I thought if the other side is not a fraction, you cannot divide.
No, you can actually in mathematics. If you have something like 1 over 2 times 4, even if you have minus 2 here, you can actually simplify this one. They are multiplying each other. Do you understand?
Yes.
Yeah. Motibo. Okay, good. Motibo. Rachel, what happened? It's not clear. What was your question? What's the challenge? You cannot talk? All right, so let's go by it one more time. But I think it's clear actually. So check the things they didn't give you, right? Consider the stuff they didn't give you. So anyone they didn't give you, they gave us S, they gave us U, they gave us A, they gave us T. They asked us to find S actually. So, but that means they gave us S. They gave us information about S. So, but there was no information about V. So, which means I'm going to use the equation that does not contain V. And that equation is this. So, U is 20, T is 5. Now, I have 1 over 2 times 2 times 5 squared. Stephanie, what's your question?
Sorry, it's a mistake.
Okay, times 5 squared. So now, I will now have that 2 will cancel 2. 2 divided by 2 will give me 1. So that 1 times 5 squared will give me 5 squared. Does it make sense now? So that x is equal to what? 100 plus 25, which will give us 125. Any question? Are we on the same page now? Rachel, do you understand what I said? Okay, thank you. Thank you, guys. Thank you. So now that's for that. Now the next example is example 4. A car increases its velocity from 10 meters per second to 30 meters per second over a distance of 100 meters. Find its acceleration. So a car increases the velocity from 10 meters per second. So from means that your u is equal to 10, right? To v means 30. That is 30 meter per second. This is 10 meter per second. Over a distance of 100 meter, it means that S is equal to 100. And then you are asked to find what? X is 100. X equal 100. And you are asked to find what? Find its acceleration. So they mentioned the acceleration as well. So A is unknown. So which means that they gave us 4 variables. So we look for that equation that does not contain that one that was mentioned. Which one wasn't mentioned? They didn't mention anything about the time. So we're going to use no information about time. So we use the equation that does not contain time. And what formula is that does not contain time? The equation that does not contain time is the one that doesn't contain time is v squared equal to u squared plus 2as. No, the first one contains time. Is the third one. V squared equal to u squared plus 2as, right? It doesn't contain time. So I'm going to apply that very formula, that v squared equal to u squared plus 2as. So formula to be applied, we have that v squared equal to us plus 2as. So this is 30 squared is equal to 10 squared plus 2 times acceleration here. Let me use capital letter so that I always know that this is A times A that I'm looking for multiplied by 100. So this is 30 squared should give us 30 times 30 should give us 900. Am I correct? So this will be 900 is equal to 100 plus this is 200A. So I should have 900 is equal to 100. Sorry, let's collect like terms. So we're going to have 900 minus 100, normal mathematics, is equal to 200A. So let's subtract both sides. I will have 800 is equal to 200A. So I'll divide both sides by 200 because I'm looking for A. Divide there by 200. And when we do, we should have here we cancel here cancel here cancel here cancel here. 8 into 2 will give us 4, right? So that means that our acceleration is equal to 4 meter per second squared. All right, any question on that? Now, any question? Everybody on the same page. So the fifth example is that a stone is dropped from rest. A stone is dropped from rest. Sister Susan, what's the problem? Can you tell me what the challenge is? Is it the mathematics? Kilo shele, go. So what happened? All right, so Susan, look at what I did, right? What's it? Let me know what the problem is so I can know what I'm explaining now. You gave me a thumbs down.
So I will explain. Can you please like explain that? Let me just explain the first in that question. I don't understand it. Like the way we do the calculation. Can you please explain it for me back again?
Okay. All right. So they said they gave us but you know how to apply the equation. You know how to pick the equation to use. Do you know how to pick the equation to use?
Yeah.
Okay, so just the calculation. So let's go. Now, the U, they gave us V. V is 30 squared. So I plugged in my 30. V is 30, I plugged 30 squared. U is 10, I plugged 10. 2 times A is what I'm looking for. X is 100. So 30 squared will give me 900 is equal to 10 squared is 100 plus 2 times 100 will give me 200. Then you have your acceleration. So collect like terms. Let this one move over to this side. And when it moves over, the sign is going to change. So that will give us 900. If plus is here, it changes to minus. Let's assume that what I had here was minus. If minus crosses over the other side to change to plus. But what I have is plus 100. Any number standing on its own this way, it has plus in front of it. Invisible plus. If I have 9, I have invisible plus. But we don't show that unless it's a negative sign, then we'll show it. So now it's going to cross over to this sign of the equation. So I'm going to have 9 minus 100, which will give me 800. Then I have 200A. But what I'm looking for is A. So I'm going to divide both sides by the coefficient of A, which is 200. So divide both sides by 200. and I'll end up having that acceleration is equal to 4 meters per second. Does it make sense now?
Yes,
Are you
sir.
sure?
Makes sense. Yes, sir.
Are you sure? Or you're saying it so you can have mercy on me? Don't have mercy on me. If you
No,
don't understand,
it's not like
let
that.
me know. I'll explain
No.
again. Okay, you understand. Okay. Thank you so much for understanding and for having mercy on me. All right. So let's go. A stone is dropped from rest, right? So when you hear it is dropped from rest, what does that tell you? That U is equal to what? 0. How far does it fall in 3 seconds? They said take G to be 10 meters per second. So if you check the information that was given to us, they gave us the following information. They said that it was dropped from rest. That means that U is equal to 0. They said how far does it fall? X, we do not know. They said it takes 3 seconds. It means that T is equal to 3 seconds. They said take G as 10 meters per second. So it means that acceleration is equal to 10 meters per second. So 4 variables was given. S was given, U was given, A was given, T was given. The one that was not given is what? V was not given. So I'm going to look for that one where V was not given. So let's see the equation that does not contain V, right? So equation that does not contain V, chup, 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 chup. The one that does not contain V is equation number 2 does not contain V. So we're going to apply that very equation number 2. But over time, the more you solve, you know the one that does not contain which, it becomes easier for you, right? So that S is equal to, I'm just going up and down for us to be sure we follow, UT plus half AT squared. But over time, you don't need to be doing that. You are looking for S. They said that this one is 0. 0 times 3 plus 1 over 2 times A is 10 times time is 3 squared. So X is equal 0 plus I have this something as saying 1 over 2 times 10. You can divide through, 2 can divide. Does it make sense? Right? So 2 can divide, gives us 1. 2 can divide it to give us 5. So you're going to, I know that division might confuse people, but I hope you are following. Times 3 squared is 9. So that S is equal to 0 plus 45 is equal 45. So that X is equal to 45 m. So the distance.
Okay, you're looking to 3 now. To the 3.
I didn't hear you, boss.
Did
So
you include the 3? The 3.
I didn't include which one?
Time. 3 for time.
Yeah, I did. 3 squared is 3 times 3 is 9.
No, I understand
Yes.
that 0 times 3 is 0.
Yeah, 0 exactly. So the distance is equal to 45 meters. All right, my people. So any questions so far? Do you understand up until this point? Do you understand up until this point? So just give me a love emoji. Let's know you are following up until this point. Right, Stella? Yeah. Paul, Shedrack, Justice. Okay, you no one give me love. Love what they find. Well, I know go see again till the next class. You no one give me. They're giving me thumbs up. Okay, okay, everybody intact. All right. So let's proceed. So in summary, we started the class by talking about distance and displacement. And we said that distance is total length of the path traveled by a body, right? So distance is a scalar quantity, like I rightly said, and it is always positive. And it has magnitude only. There's nothing about direction. So it just depends on the path taken, right? So distance is simply speed times time. Then we spoke about another quantity, which is your displacement. And we said that displacement is the shortest distance between the starting point and the final point. So there's a starting point and there's a final point. So that shortest distance between that starting point and the final point is measured in a specific direction. Direction is very important as long as we are speaking about displacements. So displacement, it does not depend on the path taken. Vector quantity is a vector quantity. It has both magnitude and direction. And one key thing about it is that it can be what? It can be positive or negative or 0 as well. So that is what makes up your what? Your displacement, right? Very key variables, 1, 2, 3, 4. Now I went ahead to solve some questions. when they ask us to find displacement is just trying to tell you total length traveled by a body, total length. So if I go 3 kilometer east, 4 kilometer west, I'm calculating the distance. I don't want to care about the direction. I'm only concerned with the total length that was covered. And you saw how we added them together and it gave us 7 kilometer. Then for displacement, I said we have to account for the compass bearing here, your current 4 cardinal points, north, south, east, and west. And I said, let's use a convention. And in this convention, let's have that this side is positive, here is negative, here is positive, here is negative, just to maintain your graph, the way you do your graph, right? So we went ahead to say that for that question, -4 is west, east is positive, which is 3. We'll bring them together. -4 plus 3 will give us -1. So it means that the displacement is 1 kilometer. The magnitude is 1 kilometer. But the sign symbol is telling us the direction, right? So remember that displacement is a vector quantity having both magnitude and direction. So magnitude here is 1 kilometer. The displacement now is what? Sorry, the direction now is the west, which is that symbol that we have right there. So we went ahead to solve another question where the man was moving around from west to east, back to west, and the rest of them. We applied the same thing. We got -4. The negative sign simply means that that is the direction because displacement is a vector quantity and the magnitude is 4. So the answer is what? 4 kilometer to the what? To the west. In your past question, you're not going to see -4. You will see 4. We are going to see 4 kilometer west, 4 kilometer north, 4 kilometer this. So it means 4 kilometer to the west. That's what this negative sign implies. And I even wrote it right here. Then we also have an example where you move to the east and to the west, but the distance is total length traveled. Now we have our example 4. And this is the case where he has left the straight line. He's no longer traveling either on the west, that straight line, or north and south. It is now moving from west to north, or from east to north, or from south to west. You understand? You've changed your cardinal points. You're no longer moving in a straight line, either west to east or north to south. So anyone, if it is north and south, just put the sum together. West and east, put the sum together. So, but this one, it forms an angle. They are perpendicular to each other. So to look for the displacement, we applied our Pythagoras theorem. And then to find the direction, unlike the other one, if it is negative, that negative sign tells you the direction, right? If it is west or north or east or west. But here, you need an angle. And how did I get the angle? I made use of my SOHCAHTOA. And that SOHCAHTOA gave me 53 because they gave me what? That very thing gave me, here is the opposite, the side facing the angle. And the side facing the 90 degrees is your hypotenuse. So opposite and adjacent. And I applied tan theta. And that was exactly how I got the direction. So the magnitude is 10 kilometer and direction is 53. So tan inverse for the direction, the magnitude you're going to use Pythagoras theorem. So I have an example, and I said that if you leave a particular point and go around and still come back to that same place you started from, then your displacement is equal 0. So let's write it down right here. So that displacement is what? 0. So displacement is equal to 0. So that's the concept I want you to always remember as long as this is concerned. All right, so let's proceed. So I said, if the movements, Justice, what's the question? Go ahead.
The one you said that the displacement is 0, does it only go for the ones in alphabet?
No, anything. Let's say if I travel 50 kilometers to this place, you have to do with just normal question, right? But if they give you values, you can calculate it and also get this thing to be 0. Maybe it depends on the values. 50 kilometers minus this for your hair, it depends on the values. All right. So note, if the movements are along the same straight line, you add them together. But take note of the sign: left, right, straight, down. That's for straight lines. If the movements are perpendicular, that 90 degrees, use your Pythagoras theorem. That means when you're moving from east to north, from west to south, you're changing. So just same principles about your resolution of vectors. So we left that and we spoke about speed and velocity. I will say that speed is the rate of change of distance with time. And we say that speed is distance over time. And speed is a scalar quantity. And it has no direction. And it's always what's positive. And we went ahead to say that velocity is the rate of change of displacement with time. So velocity is a vector quantity and it has direction. It can be positive or negative. So anytime you are changing direction, you are talking about velocity. So once it's a change of direction, there is change in velocity. No change in direction, which means that velocity is not changing as well. So velocity is a function of your direction. right? So I now said, what happens when I'm moving around the circle? And we agreed that the speed can be constant. And I said that speed is how fast or how slow you're running, right? So if you're medium, you're not running fast, you're not running slow, you're just at the center, just maintaining a constant space, right? And you're moving around the circular path. Because your position is changing, we say that what happens here is that velocity is changing. Because of what? Because of direction, right? Velocity is changing because you are changing direction. All right. So the next one is velocity and acceleration. So acceleration is the rate of change of velocity with what? With time. Rate of change of velocity with what? With time. So this is acceleration, is changing velocity over what? Changing time. So note that acceleration occurs, I said that it depends on three things: speed and velocity. And velocity is a function of what? Direction. So if speed is changing, it means that my acceleration is changing, right? If direction is changing, it also means that my acceleration is changing. So remember that direction changing means that velocity is changing. Is that okay? If acceleration is direction is changing, it means that velocity is changing. But sometimes you can have that the speed is not changing, but the velocity is changing. That also means that acceleration is changing. So if one of them is present, it means that it is what? Changing. So I said it is important to note that even if speed is constant, acceleration can change. Acceleration can exist if direction what? Changes. So acceleration can do exist if that one is changing as well. So I used something about being present in a meeting. I used your PTA for an example. And I said in that PTA, your mom is the speed, your dad is the velocity, which is also the direction. So if your dad is in the meeting, it means that your attendance is marked. They will not tell you to pay any money. If your mom is in the meeting, they will not ask you to pay any money, which means they attended. If both of them is in the meeting, it also means that you attended and they will not pay any money. Do you understand? So that's the same thing about what? Acceleration and velocity and speed. And velocity has to do with what? Direction. So your father's name is not that is not father. He has a name. So, but that father is the velocity. Then your father's name in particular. Let's say I give birth tomorrow. Then my son will be like my father. So he will mention my name. So that's my name as the direction. But father should be present in the meeting, or mother should be present, or both of them, for us to say that the child has attended PTA meeting. So we went ahead to talk about a car that moves around. I gave a question which some of us answered in the class. So which statement is correct? We say that it is going to be what? Directed towards center because of what? Though the speed is constant, which means the mom is not changing, right? But I'm moving around the circular track, which means my direction is changing. And because of that, we said that the second one we hold, right? Circular track, right? Which implies that because direction is changing, in brackets, so velocity changes. Are we there? So hence B is the answer. Hence, comma, B is the answer. So that was the structure I drew in class, right? That was the structure that we used. So after that, we answered other questions, right? When do we say that acceleration is changing? When do we say that it is not changing? So that was what we did, and we answered some questions on that. So after that, we now move to types of motion, right? I said that we'll have translational motion, we'll have rotational motion, we'll have oscillatory motion, we'll have random motion. I gave examples on this. A car that is moving, human being moving from one place to another. Rotational, just like your fan, even your wheel that is rotating when you're moving. Oscillatory motion, I said simple pendulum. I said that swing to and fro. We also said, your pendulum bob and the rest of them is a part of that oscillatory motion, and random motion as well, which means smoke and the rest. So you answer this very question, oscillatory. You answer this one, the wheel is rolling and is moving forward as well. So we also have the equations of motion, and I said that you only use this equation when the acceleration is constant. If acceleration is not constant, you're not going to apply this. And these are the common phrases that we use for your equation of motion. And then I said, these are the 4 equations. We made use of SOLVAT, and I said the 4 equations must contain 4 of them. Each of those equations contains 4, and one of them will be missing. So anytime you are given a question, just choose that equation that does not contain the missing variable. That will solve your problem. And I gave you these topics. U is equal to 0, initial velocity when the body starts from rest. When a body is brought to rest, that V is equal to 0, that's final velocity. And when you are falling from you have a free fall, the initial velocity U is equal to 0. If an object is thrown upwards, that V is also equal to 0. So these are the 4 rules I gave you. And then we'll solve some examples to see how we can apply the rules. So for this first one, they gave us the acceleration, we ticked it. They gave us time, we ticked it. They said it starts from rest, that means that U is equal to 0, we ticked it. Find the final velocity, we ticked it. They didn't say anything about distance. So we're going to use that very equation that does not contain distance. So that's how to know the equations to use. So these are the things that we did in today's class. And I hope that a short do made sense. Any questions so far? So I can say that we've officially come to the end of today's class, right? In our next class, we'll be looking at how to distance time graph. Distance time graph. Distance time graph. Yeah, we're looking at distance time graph. Good. If you enjoyed today's session, can you say something on the group chat, on the chat here?